Hello everyone. So welcome back to our latest lecture session. As is customary, let's have a quick recap of what we discussed in the previous session. I believe you are trying to look at applications of Vmintech with respect to closed systems initially, and then also open systems. And we looked at how the relevant values for pH would change, let's say, when you have the system in equilibrium with partial pressure of carbon dioxide or in equilibrium with carbon dioxide in the gaseous phase. And more or less in the last session we spent time about how to look at using Vmintech to cut down on your time for analysis. Yes. So in this case we are going to in today's session we are going to move forward and look at some more practical applications. And I guess one common aspect that people come across is you have solution A and solution B, you mix them up, and what are the properties of the solution C, let's say, or the mixture now, right. So obviously you can again conduct the relevant titrations or analysis and get it done, or if let's say the quantities are conservative, this is something we are going to come back to. Keep in mind that if the quantities are conservative, you can look at the relevant mass balance or balance on the conservative quantities, right. So let's just look at what we are trying to analyze here. So here we have, let's say, an example, right, and here we are talking about mixing problems now. Yes, here let's say we have an example, and let's say we have a solution at volume V, right, and the pH is 6, and again let's say the pH is 8 of a second solution, again with, let's say, for ease of understanding, again the volume is the same V, right. So now we have two solutions, each of the same volume, one at pH 6 and one at pH 8. And obviously let's consider or assume that you have the different other what do we say compounds present in these two solutions now, right. So let's say if I am concerned with, okay, what's the pH of this solution going to be now, right, that's something that that would be required, let's say, for further analysis. So what are the different ways people look at? Let's just have a look at what people are up to in general, right. So one case is, right, taking the average of the two pH values, pH 1 and pH 2, right, or 6 and 8, and people say we end up with 7. That's one thing that people do often. Okay, let's go step by step or analyze that. So why is this not true though? This is not the true value, and why is this? So in the first case, this is pH logarithm of H plus, so it's not something that you can just sum up, right, or add or take the average of, right. So anyway, that's something that fails right there. So then what do people try to do? People try to calculate the concentration of H plus for solution 1, right, and also concentration of H plus for solution 2, and then take the average of these values, right, and then get the pH of the mixture now. Well, this is one way. Again, this would work if H plus concentration was a conservative quantity. But as you now know, with some or considerable background in acid base reactions and such, that H plus is not conservative, let's say. There are other compounds, let's say, any other bases present, let's say, that can take up your H plus or such. So you can't just take the average of the two H plus concentrations and try to get at or try to use that particular methodology to calculate your pH though, right. So obviously the key here is you are going to look at balances on conservative quantities, and pH and H plus concentrations are not conservative quantities. So looking at what we have been through recently, let's say, what have we discussed now? What are some of these conservative quantities? So again, the whole key is that we look at components. As you know, components, the total component concentrations are going to be constant. So for example, CO3 total is something that's going to be constant. And similarly, you can also consider, let's say, something relatively new that we discussed in the last couple of sessions, alkalinity, I guess, right. So let's say depending on your particular scenario, alkalinity, let's say, is going to be constant, and you can look at the or consider the use of alkalinity to be able to arrive at your particular variable. So let's just have a quick look about what we are discussing, I guess, right. So how can you go about that, let's say. So as we just discussed, what are the conservative quantities that you can use, or conservative quantities, what are they, right. So obviously from our component balance, obviously we know that the total components are going to be a conservative quantity. And what else have we discussed recently? We looked at alkalinity, and obviously we also talked about or discussed about acidity, right. So these are variables that you can conduct the balance on, because they are conservative quantities, right. So let's just look at one particular scenario, right. We are going to look at how to solve a particular system by hand, right, and another case how to solve it by Vmintech, let's say, right. And we are going to look at how to solve it by hand, even though we can solve it easily by Vmintech, because we need to understand the fundamentals or the basics here, right. So by hand, so what are we trying to look at here? Let's say we have pH of a solution given, right, and also alkalinity of a solution given, pH 1 and pH 2, right, and also let's say I also have, alkalinity 1, pH 2 and alkalinity 2, let's say, let's say I have two solutions and I want to know, let's say, the pH of the mixture now, right. So how do I go about it by hand? That's what we are going to discuss that, right. So again by hand now, let's look at some of the equations that we are aware of, and what do we know? We know that alkalinity is equal to what now? All the bases, let's say, HCO3 minus plus 2 times CO3 2 minus, and why do we go with 2? Because it can, CO3 2 minus can neutralize 2 H plus or 2 protons, and OH minus, and then minus H plus. Again, thus obviously the theoretical definition of alkalinity, which considers that only the carbonate species are the predominant acid base species, right. So this is a particular equation that we have, let's say, so for solution 1, right, and that's going to be equal to what now? Alpha 1 plus 2 times alpha 2 into CO3 total plus Kw water dissociation constant by concentration of H plus minus concentration of H plus. And how do we end up with this? Just a quick recap again. Ionization fraction alpha 1, what would that be equal to? HCO3 minus by H2CO3 plus HCO3 minus plus CO3 2 minus, right. That is nothing but equal to HCO3 minus divided by what is this denominator? It is nothing but CO3 total, right. And similarly, what is alpha now? Alpha 2, pardon me, it is going to be equal to CO3 2 minus by CO3 total. And while we are not using this particular alpha naught, let us see what that is equal to. That is obviously equal to H2CO3 by CO3 total, right, to refresh our memories. So again, plugging these values of alpha 1 and alpha 2 in this particular equation here, we end up with a simplified form, alpha 1 plus 2 alpha 2 into CO3 total, and so on and so forth. So again, let us look at what we have here. What are the knowns and unknowns? So here alkalinity is a known value because it is given here, right. Alkalinity is a known value, and CO3 total is an unknown, right, it is a variable, but you know the pH, right. So H plus is a known value here, and for a given pH you can calculate obviously alpha 1 and alpha 2, right, and that is something we are aware of. So I am not going to again plug that in here. So from here what can I calculate? I can calculate the CO3 total 1, right, I can calculate that. Similarly for solution 2, I am going to go ahead and calculate CO3 total 2 in the same manner, right. And now what can I do now? Let us say, right, now I am able to calculate CO3 total of 1 and CO3 total of the second solution. So how do I go ahead further? By calculating or by trying to solve the solution for pH by hand. The key is we are still looking at by hand. So again, what is this particular case that we know? We know that again alkalinity is equal to alpha 1 plus 2 alpha 2 times CO3 total plus Kw by H plus, right, Kw by H plus minus H plus. So let us say now this is for the mixture now, right, the mixture where we mixed up 1 and 2, let us say, right. And how do I go about calculating it now, right? For this case, I can calculate alkalinity. How do I calculate alkalinity now? I can say V1 into alkalinity 1 plus V2 into alkalinity 2 is going to be equal to V3 or the volume of the mixture, right, into alkalinity of the mixture, right. And we know volume 1, alkalinity 1, we know volume 2 and alkalinity 2. Vm is nothing but Vm V1 plus V2 obviously, right. So here what is this equation expressing? It is that we are balancing the alkalinity, total alkalinity, right. So the alkalinity of the mixture is now going to be calculated from this equation. All the others are known variables, right. And similarly, I can also calculate the CO3 total of the mixture. And how do I do that again? Just plug the relevant values in. CO3 total 1 plus V2 into CO3 total 2 is equal to volume of the mixture into CO3 total of the mixture, right. Again, V1, V2, Vm, we know those values. CO3 total 1 and CO3 total 2, we calculated them earlier, right, from this particular case here, right, we calculated them. And now by the balance on CO3 total, I can come up with calculating the CO3 total of the mixture, right. That is something that now I am able to calculate. So now I have, what do I have please? I have the alkalinity of the mixture, and I also have CO3 total of the mixture. Again, the key is trying to understand why am I only balancing the relevant conservative quantities. Again, the key is that they are conservative as the name indicates, right. So if you are looking at H plus though, and if you are trying to do the balance on H plus, let us say, as in V1 H1 plus V2 H2 equal to V3 H3, what is going to be the issue now, right. You do not know, or because here we do know that we have CO3 2 minus or HCO3 minus. The H plus can either be taken up by them or released from H2CO3 and so on. There are other interactions here. So you obviously only can conduct the balance on a conservative quantity, and as we know from our background, CO3 total, that is not going to change, right. Whatever happens, the total CO3 is going to be the same, and same case with alkalinity. So that is why we are we need to consider only the conservative quantities when we are looking at the balance. And thus in this case where we had the alkalinity, we first calculate the CO3 total of both the solutions, and then looking at the balance on both the solutions with respect to alkalinity and CO3 total, we end up with calculating the alkalinity and CO3 total of the mixture, right. That is what we have here. And once we have this, what can I do? I can again go back to this equation, right. And what do you have? I have the alkalinity of the mixture here, I have the CO3 total of the mixture here, right. Kw is a known value. So what is the only unknown here? It is H plus, right. So from this I can end up calculating what is the H plus, right. And once I have the H plus, obviously I can calculate the pH, right. And again alpha 1 and alpha 2 are, as you are aware of, functions of H plus. So that is something you can plug in. So what can you use? I think one way, obviously by hand might be a bit difficult. So in Excel you can go to solver, there is a function called solver, right. It should be in add-ins, I guess, and with that you can be able to easily solve for what do we say, H plus here in this particular equation, yes. So we just looked at how to solve this by hand. Again, what was the crux of our what do we say methodology, I guess, that we are going to conduct a balance on conservative quantities. So now let us try to see or try to understand how we can use vMinTech to cut down on our time and get at the same solution, right. So again let me just go back here. So we have, do we have? We have pH and we have alkalinity, right, pH 1 and 1, and again pH of a second solution and alkalinity of a second solution, right. So again what can I do here? So I can, this is by vMinTech, the approach by vMinTech, right. How do I do that? So for the first solution I am going to plug in pH and alkalinity, right, as known values, and from the relevant concentrations what can I calculate now? I can calculate CO3 total and H total, right. And same case here, I will plug in pH 2 and alkalinity 2 for the second solution, and what can I calculate? I can calculate CO3 total and H total, right. So then again what can I do now? H total again is a conservative quantity, so V1 into H total 1 plus V2 into H total 2 is equal to volume of the mixture into H total of the mixture, right. So from this particular balance equation we can now calculate H total of the mixture, right. So unlike H plus concentration, H total is a conservative quantity. H plus is not a conservative quantity, but the total H is a conservative quantity, and that is why we applied the relevant mass balance here, not mass balance, pardon me, the component balance, and we now can calculate H total of the mixture, right. And similarly I can conduct the balance on what now? CO3 total, which we looked at earlier, and I can then calculate CO3 total of the mixture, right. I can have that too. And again what do I have? H total and CO3 total. So, I can just plug in these two values in Vmintech, and what will I end up with? I will end up with the pH of the mixture, yes. So, again as you just see, unless you have the understanding of the fundamentals here with respect to the conservative quantities or such, you can't, or it would be relatively difficult for you to look at or using Vmintech. But obviously something that takes you around half an hour or 40 to 50 minutes to work out by hand, by Vmintech you can cut down the time to 5 to 10 minutes, right. Again, so let us now look at an example problem, right, and let us see how we can analyze that particular problem, I guess, right. So, let us first understand the question that we have. So, obviously it is similar to what we just discussed. So, it says we have 2 liters of solution A and 3 liters of solution B, right, and we have the pH, or this is the analysis for the particular for the individual compounds or the solutions, pardon me, and for the first one is pH 7.2 and alkalinity is 200 milligram per liter as CaCO3, and again water 2 or water B, I guess it is 8.4 pH and 400 milligram per liter. Again I guess the first question should be something that we should be able to solve easily, and then I guess there are a few more questions here which might require a bit more understanding, I guess. So, let us go through and try to solve this particular question. So, we have pH 7.2 and 200, this is for water or solution 1, and 8.4 and 400. So, by hand we are going to try to solve this by hand, right. So, how do I solve this by hand now, right, and we just looked at that earlier. So, I have the pH and I have the alkalinity, right. So, how did we try to solve this now? I believe we tried to solve this by calculating the CO3 total, right, and how do I solve that? I said alkalinity was equal to, right, alpha 1 plus 2 times alpha 2, yes, into CO3 total plus Kw by H plus, and what is this? Nothing but OH minus, right, minus concentration of H plus, right. So, from here what can I calculate here? I know alkalinity, I know alpha 1, alpha 2, H plus and Kw. So, I can calculate CO3 total of solution A, right, but this is going to take some time, right, and what can you use to solve for this? Let us say you can use Excel, and in that particular case you can look up solver, a function called solver, yes, and then use that to solve this, but obviously it is going to be a bit tedious now and I am not going to go through that, right. Again same case, how do I do the same case? I am going to repeat that for CO3 total B, and I am going to calculate CO3 total A, and similarly I am going to calculate CO3 total B, yes, and then obviously what next? Let us just try to write this down, right. So, I have V1 into alkalinity 1 plus V2 alkalinity 2 is equal to V3 into alkalinity 3, right. So, here I have V1 should be 2, I think, and this was 200 milligram per liter, and this particular V2 was I believe 3 liters, and alkalinity 3 was 400 milligram per liter as CaCO3 if I am not wrong, and V3 is nothing but V1 plus V2 because we are mixing the two solutions. So, it is 2 plus 3 is equal to 5 into alkalinity 3, and alkalinity of this particular solution or the mixture, what is that now? 400 plus 3/4 1200 by 5, and anyway that is going to be equal to 1600 by 5, and you can end up calculating that particular value, I guess, yes. And similarly applying the same particular balance on CO3 total, right, I will end up calculating CO3 total of the mixture. Let me write it down as mixture, right, okay. CO3 total of the mixture in the same particular equation, applying a similar equation, I guess, and I have alkalinity of the mixture and CO3 total of the mixture now, right. And how do I proceed further? As we looked at it earlier again, alkalinity of the mixture is going to be equal to alpha 1 plus 2 times alpha 2 into CO3 total of the mixture plus Kw by H plus minus concentration of H plus, and what is the only unknown here? It is only H plus, right, because you have alkalinity of the mixture which you calculated here, right, you calculate here, CO3 total of the mixture which you calculate here, and as we know alpha 1 and alpha 2 are nothing but functions of H plus. But again solving this by hand is going to be tedious, and you can use Excel solver, or if you have any other mathematical tools or such at your disposal, you can use them to solve for this particular function. So anyway, that is by hand, but obviously it is going to take quite some time. So at least we are going to walk through it in detail with respect to how to solve it by Vmintek, right. So let us look at the solution again, not solution, pardon me, the question again, and let us just see what we are up to. So we have pH and we have alkalinity, and what is that of the mixture, and what was the approach earlier, right. We need to calculate the CO3 total and H total of both the solutions, right. CO3 total and H total of this particular solution, and same case CO3 total and H total of this particular solution. And how are we going to do that? We are going to use Vmintek, I guess, 7.2 and 8.4 and 200 and 400. So let me see how to use Vmintek, right. So first we need to set up the relevant aspects. So the first one is pH is fixed at, I believe it was 7.2, right, 7.2, yes. And what else do we have? We have alkalinity, and I think we can specify that in parameters, and alkalinity was as CaCO3. I don't need to change the units because I have them, I have the relevant units mentioned here, and I believe it was 200 milligram per liter, right. So I am going to say okay. So alkalinity is specified in this problem, yes, and so on, normal, and going on to okay, and I am going to say run Vmintek, and I have the relevant species, concentration of the different species here. Again, what does this mean? These are the different compounds that are going to be present at equilibrium, right, and this is what we these are the relevant concentrations that Vmintek calculates. And again, the binding or one of the boundaries that we specified was pH is 7.2 and alkalinity, obviously. So first now we need to calculate CO3 total and H total, right. Obviously there is no shortcut, we need to go to print to Excel, and that is out here. And how do I calculate this particular CO3 total, right? That is going to be equal to, and equal to this particular CO3 2 minus plus H2CO3 plus HCO3 minus, right, and enter. So what is this equal to again? If you look at this, we know that CO3 total is nothing but H2CO3 plus HCO3 minus plus CO3 total. So to calculate CO3 total, what did I just do? We just summed up the concentrations of the three what do we say, species relevant of the carbonate system, H2CO3, HCO3 minus and CO3 total, right. And so the CO3 total that we end up with is, after summing up CO3 2 minus H2CO3 and HCO3 minus, that is equal to enter please, 4.5 into 10 power minus 3. So let us write that down somewhere. So we end up with 4.5 into 10 power minus 3, right. And let us look at H total. So anyway, CO3 total, let us just try to refresh our memory, I guess. So we have H plus here components and CO3 2 minus, right. And what are the species? They are H plus, OH minus, H2CO3, HCO3 minus and CO3 2 minus. And how many H plus here? 1, minus 1, H2CO3 is 2, 1, and here it is 0, and CO3 2 minus here it is 0, 0, 1, 1, 1. So what did we just do, or how did we calculate that? We just did the total balance on the component CO3 total, and that was equal to 1 times H2CO3, 1 times HCO3 minus and 1 times CO3 2 minus, right. And with that we end up with the value of 4.5 into 10 power minus 3. So similarly we need to calculate what is it now, H total, and what is that equal to? H plus plus 2 times H2CO3, 1 times HCO3 minus and minus OH minus. So let us see if we can calculate that, right. So that is equal to please, okay, and we had it equal to H plus what else please, HCO3 minus plus 2, okay, 2 times into H2CO3 minus OH minus. So, what do we have here? We have H plus, plus HCO3 minus plus 2 times H2CO3 minus OH minus, right. Enter please. And so, now we end up with a H total of let us say 5.1 into 10 power minus 3. Let me plug that in here. So, now I end up with a value of 5.1 into 10 power minus 3, right, approximately. Let us check that again. So, 5.1 into 10 power minus 3, and earlier we end up with 4.5 into 10 power minus 3. So, with that we are done with the analysis for part A or solution A. Now, we need to repeat the exercise for solution B, and what do we have? 8.4 and 400. So, let us just close this Excel, or let me anyway that is fine. We will close this Excel and we will move on to VMinTech here, back to input menu, and now I need to change it such that this particular pH is now 8.4, I believe 8.4, right. And in parameters we are going to specify the alkalinity, and the alkalinity now was or is, pardon me, going to be equal to, I believe 400, right, and 400 and okay. And sometimes we need to be careful about this. So, let us go back here and then run VMinTech, and now again we see that the pH is fixed, that is why the pH does not change, and we have again the relevant species. So, again we need to repeat the same exercise as earlier. We need to go to print to Excel, and I am doing that here, right. So, first we are going to calculate the CO3 total. So, that is going to be equal to CO3 2 minus plus HCO3 minus plus H2CO3 and enter, and we are now having something like 7.9 into 10 power minus 3. So, let us just write that down first. So, it is 7.9 into 10 power minus 3, that is the CO3 total of the second solution, or which is B. And let us again go back, and what else were we considering? I believe we need to go back to Excel, and same case as earlier, we need to calculate the H total, and that is equal to H plus 2 times into H2CO3 plus HCO3 minus, and what are we missing? Minus OH minus, right. So, enter please, and again it is 7.9 into relatively similar value, 7.9 into 10 power minus 3. So, let us just check if we have the right calculation here. So, we said H plus and minus OH minus, that we are done with, 2 times H2CO3, and B5 is HCO3 minus. Yes, so we are on the right track. Enter please, and we are going to approximate it by 7.9 into 10 power minus 3, right. And where do we have this? Same H total is again 7.9 into 10 power minus 3, right. So, now what next? We need to calculate the CO3 total of the mixture, right, and also H total of the mixture. And how do we do that? Based on the balance that we talked about earlier, which is nothing but V1 into CO3 total 1 plus V2 into CO3 total 2 by V1 plus V2, which is I believe 2 plus 3 5, right, 2 liters and 3 liters. So, let us just plug this in for both the cases and see what it turns out to be, right. So, let us go back to Excel. Hopefully, we can remember the values, or we can come back to this particular slide. So, first we are going to try to calculate CO3 total of the mixture, right. So, we are now going to calculate CO3 total, that is equal to V1, which is 2 into, and let us check the value of our CO3 total, and that was 4.5 into 10 power minus 3, right, and plus and volume 2 was 3. So, in 3 into, and let us check CO3 total once, and what was that? That was 7.9 into 10 power minus 3, right. So, enter. So, I am going to say this, I need to divide this by the total volume, which is 5, that is equal to this cell by 5 divided by 5 and enter. So, now I end up with the value of 6.5 into 10 power minus 4. So, let me write that down. So, the CO3 total of the mixture that I now have as 6.5 into what was the values 10 power minus 3, pardon me, 10 power minus 3. So, I am done with this. Similarly, I need to repeat the exercise for H total, right. So, let us have that particular case here. So, H total, that is equal to 2 times, and let me switch and see what the H total value is. Where do we have that here? It is 5.1 into 10 power minus 3 into 10 power minus 3 plus 3 into 3 is again the volume, right. Let us check the value of H total here, that is equal to 7.9 into 10 power minus 3 and enter please. And now we are going to have to divide it by V1 plus V2, that is equal to this cell divided by 5, that is equal to 6.8 into 10 power minus 3 approximately. So, let us plug that down somewhere, 6.8 into 10 power minus 3. So, now we have two values. What are they here? H total and CO3 total of the mixture, right. Now, I can easily calculate the pH of the solutions. So, we are going to plug in the two components, they are CO3 2 minus, and I am going to use the accurate values, not the approximate values that I used earlier. So, from my calculations we will end up with 6.61 into 10 power minus 3. So, I am going to add that to the list, and then again H total, and where is that here? That is somewhere out here, and H total, the accurate value should be 6.76 into 10 power minus 3, and where is this? We have to change it to 76, that is 6.76 into 10 power minus 3, yes, that is right. So, I am going to add that to list. So, one key aspect is you need to remove the alkalinity from this particular iteration, because we added alkalinity earlier and you can't have that given that here, which you already did. So, I am going to run it now, right, and now we end up with the pH of 7.8, right. So, again 7.2 pH was our initial case, right. Let us just look at our question here. So, 7.2 and 8.4, but alkalinities were 200 and 400 milligram per liter, 2 liters and 3 liters, right. So, with this particular Remintech we can cut down on the analysis time, yes, and now we know that the final pH of our particular solution is going to be 7.8, right. And obviously, if you want to look at the species concentration, we again have that here. So, at 7.8 you would expect most of it to be present as HCO3 minus. Just for a quick understanding, let us look at the distribution. So, as you see HCO3 minus predominates, that is 96 or 97%, right. So, that is what you see. Again the pH is 7.8 and this is what we want to calculate. So, we are done with part A of this particular example problem, and we are going to continue working on part B and C in the next lecture session. And once we are done with that, we will then further look at how to calculate or how to analyze the system, let us say when your theoretical alkalinity does not suit your present scenario, as in theoretical alkalinity and your titrated or measured alkalinity are relatively different. So, we are going to look at those examples, and with that I am done for this session, and thank you.